Hello students, this is the first lecture of my course Hydraulics, and today I am going to discuss about the concept of fluid. Before going into the details of hydraulics, first understand the meaning of fluid mechanics. It is the study of fluids either in motion, that is fluid dynamics, or at rest, that is fluid statics. Water fluids are both includes both the liquids as well as gases. There are very enormous applications of fluid in engineering. Uh, we see the phenomena of fluid mechanics in swimming, in pumps, airplanes, blood flow, ships, rivers, windmills, pipes, jets, sprinklers, and there are several other applications of fluid mechanics. In engineering application, fluid mechanics and hydraulics are used in a similar applications. Hydraulics originates from the Greek word hydraulikos and olos. Hydraulikos means water in Greek. This comes from the word hydor, which means water, and olos means pipe. So water flow through pipe includes hydraulics. That's where this word comes from. Hydraulics is a technology and applied science using engineering, chemistry, and other sciences involving the mechanical properties and use of liquids. Now you must have a slight idea about the difference between fluid mechanics and hydraulics. Have you got the idea? Fluid mechanics includes both the fluids, that is water, or not water, but you should say liquid, as well as gases, whereas hydraulics mainly includes liquids only. This is the first one, because the word hyder means water, and that is a liquid. So this is the basic difference. Whereas in fluid mechanics, we study the mechanics of both the fluids, liquid as well as gases. Whereas in hydraulics, we only focus on the liquid, but specifically water, mainly water. Okay, mainly water. This is the basic difference. Now, before going into the details, we have to know about the concept of fluid. Now, we must have studied in our basic sciences that there are three states of matter: solid, liquid, and gases. In solids, the molecules are very close to each other, or packed very close to each other. Okay, very close to each other. In liquids, the molecules are slightly spaced, not very close. And in gases, the molecules are very far apart. Okay, this is the basic of solids, liquid, and gases. Now, liquid and gases both includes known as fluids, and this is solid. Now, solid, when we apply shear stresses, then what will happen? These molecules apply resistance to this shear stress. If we apply some shear stress, then the molecules will apply the resistance. Okay, this will not move by applying a shear stress. Whereas in fluids, both in liquid as well as in gases, what will happen? When we apply a little shear stress, then this cannot apply any resistance. This will start to flow. Okay. So fluids are those substances which offers little resistance to shear deformation. Shear deformation. Okay. So if, however small will be the shear deformation, the fluid will start to flow. That is the basics of a basic difference between solids and liquids. Now, as long as we apply shear stress to both the liquids as well as gases, this, it means fluids, the deformation will occur continuously, as long as we will continue applying the shear stress. Okay. So this is the basic difference between fluids and solids. Okay. Now, due to the molecular adjustment, since the molecules are very close, as compared to the gas in liquids, molecules are very close as compared to in gas. So the liquid have a definite volume, okay, and it form a free surface, whereas in gases the molecules are very far apart. It will try to expand. Due to this, there is no definite volume. Okay. Now we have discussed the difference between liquids, the difference between fluids and solids. Now we will discuss the difference between liquid and gases. Now, since I have already discussed that the molecules in liquids are very closely packed as compared to the gases, not compared to the solids, but when we compare the liquids molecular arrangement of liquid with that of the gases, then we will find that these are relatively closely packed as compared to the gases. Okay. And the force of cohesion, means cohesive forces between the molecules, is strong. So due to that, it will form a free surface and the volume is definite in case of liquid. And in case of gases, the cohesive forces are not so strong, so that it will expand, and this will result in the expansion of the molecules, and due to that there is no definite volume, and there will be no free surface. Okay, there will be no free surface. Okay. So today in this lecture, in lecture 1, I have covered the basics of hydraulics. I have tried to give you an idea about the fluid mechanics. I have discussed the difference between hydraulics and fluid mechanics. I have discussed different phases of a matter, that is solids, a brief detail, because this is a very basic topic, so we have already have some knowledge of these concepts, so I have just give you a brief idea. Okay. So solids, I have discussed about liquids and gases. So this was the lecture 1. I will be uploading my lectures on this website. Okay, I will be uploading all the course materials. I will be uploading all the video lectures. Okay, and also I will be uploading all the slideshows. So you just have to go through this website, and also you have to subscribe YouTube channel with the same name. Okay, so that you will get all the updates whenever I post the videos, and also I will post videos. I will also notify you. Okay, whenever I will post, but you have to be updated yourself also, no? So be prepared, and if you have any questions, you can ask questions. I encourage you to ask. Okay, you should always ask questions. So before asking questions, you should learn. You should go through some books. I will recommend you some books also. What are the books you should read? Uh, you should read fluid mechanics, by FM White. I will upload the link of soft copy on my website. Again, you have to go through this website. Okay, I will be uploading every material on this website. You will get it from that one here. Okay. Again, another book is very nice book, Fluid Mechanics by K. Subramania. And another book by A.K. Jain. These are the three books that I find very useful. So this one is very good by FM, not FM Mechanics, sorry. This is by FM White. Okay, this is by FM White. Okay. So this is Fluid Mechanics by FM White. FM White. Okay. These three books. This is also Fluid Mechanics by A.K. Jain. So all these books you should study. You should go through. Uh, Books are for reference and for details, but I have prepared lecture notes for you. Okay, you should download all the lecture notes from this website. Okay, I will be uploading the lecture notes as well as slideshows. So be updated, keep watching. Thank you.